Hi, my name is Jeff Langlois, and I decided to do my astronomy topic on black holes. Let's start with describing what a black hole really is. What is a black hole? Well, it's a region of space-time at which gravity is so strong that it prevents light from escaping. It's not just light that is prevented from escaping. There's other objects out there such as meteoroids, stars, dwarf planets, and planets that are also prevented from escaping, and this is due to the strong gravity force located at the center of the black hole. Why is a black hole black? Well, since light is unable to escape, that means that the black hole absorbs all light and emits no light, which essentially means that it's a perfect black body. A black hole can come in many different sizes, so what makes a black hole grow? Well, it absorbs any additional matter, and this tends to be gas and interstellar dust from its direct surroundings. But it also isn't uncommon for it to include meteoroids, stars, dwarf planets, and regular planets. Next, I would like to show a quick clip of a star actually being consumed by a black hole. The next thing we'll be talking about is the physical properties of black holes. Every black hole has three main properties: mass, charge, and angular momentum. There are also three different types: a Schwarzschild, which has no electrical charge or angular momentum, a Reissner-Nordström, charged black holes, and then you have a Kerr, which is just rotating black holes. There are also four different classifications. You have supermassive black holes, intermediate massive black holes, stellar black holes, and micro black holes. Now, the various masses and sizes are displayed on the screen accordingly. Let's take a more in-depth look at the Schwarzschild black hole. So it has a singularity, which is a very dense mass collective at its center. It has a radius, which is the distance from the center to the event horizon. And then you have the event horizon, which is the spherical boundary between the black hole and the outside universe. There is no solid, liquid, or gas at the surface of the event horizon. Next, we will take a look at Kerr. It has a singularity, but this singularity is infinitely thin ring around the center of the hole. It has an outer horizon, the event horizon, which is a spherical surface, and then an ergosphere, which nothing in range of this can remain at rest. It is constantly being curved or pulled towards the middle of the black hole. The last thing I'll talk about is how astronomers detect a black hole. One of the ways of doing this is by looking at the mass estimates from objects around that are orbiting the black hole or spiraling into the core. The second way is to observe the gravitational lens effect, black hole and other objects passing around it. And then thirdly, the emitted radiation is another indication of a black hole. Here's a quick little video showing the gravitational lens effect of an object passing through or around a black hole. The last thing I'd like to leave you with is just an artist's interpretation of what it would look like if a star was to be consumed by a black hole. So you have the star on the right, which is the blue object, and then you have the black hole in the middle, which is that black object. And then if you look on the very outer ring, right where you start seeing that color, is the event horizon. And so this kind of depicts the matter being sucked in to the event horizon.